Hello, my name is Sabrina Kaiser and I'm from the Shoring Lab at the University of Kaiserslautern in Germany. In our group, we are generally interested in plant growth regulation at the organ, cellular and subcellular level. And as you can see here from the title, I am currently trying to shed light on the molecular connection between the vacuole and the actin cytoskeleton. The phytohormone auxin is a crucial growth regulator and known to inhibit growth in root tissue. On the subcellular level, it has been shown in the past that the vacuole and the actin cytoskeleton are both affected when treated with this hormone. While the vacuole showed a lot of constrictions and got smaller in volume, the cytoskeleton showed a higher intensity and the network became more dense. In addition, it was also shown that this vacuolar phenotype here is dependent on the cytoskeleton. So these two are connected somehow, but in which way was not clear. We thought that the connection might be some kind of adapter protein, and two members of the NET4 family seem to be the perfect candidates for this job, since at least one of these two is not only actin binding, but also localized to the tonoplast. So to analyze these proteins, we established knockout and overexpressing lines and could see that loss of NET4 led to larger vacuoles, while overexpression resulted in smaller, more compact vacuoles that occupied less space in the cell, as shown here in % of vacuolar occupancy. This led us to conclude that NET4 modulates the compactness of vacuoles. Although the morphology of these compact vacuoles was different from the constricted morphology of auxin-treated vacuoles, the smaller vacuoles of the overexpressor also resulted in smaller cell and overall root length. The larger vacuoles of the mutant, on the other hand, did not show any effect on cellular or organ level. However, upon auxin treatment, all lines still reacted and showed changed vacuolar morphology with these auxin-typical constrictions. When looking at the relative change in vacuolar occupancy, only the overexpressor showed partial resistance to auxin, while there was no difference for the mutant compared to control. Since NET4 belongs to a superfamily of actin-binding proteins, we thought maybe some of the other NETs that normally act at different membranes could be upregulated and compensate for the loss of NET4 in the mutant. But as shown here in the graph, we could not find any transcriptional upregulation of other NETs in the mutant background. Therefore, we now think that NET4 cannot alone connect the cytoskeleton to the vacuole. Instead, we believe that NET4 either forms complexes with other proteins, as shown here, or that other proteins even work independent of NET4, as shown here. So to find some of these other proteins, we performed co-immunoprecipitation with NET4A GFP as bait and did mass spectrometry. And with this, we identified 5 promising interacting candidates, 3 RAP-GTPases, and 2 proteins that are not characterized in Arabidopsis yet, but are related to the cytoskeleton in mammals and yeast. So in the future, we plan, of course, to also analyze their function and the involvement at the vacuole cytoskeleton nexus. With this, I would like to end this video abstract and hope to see you during the poster session. Thank you for watching.